Hello everyone, we've got a big update for you today because we're doing the NAO forecast for the winter of 2017-2018, and this is essentially the starting point for the winter updates, which will actually commence in September. So this will be kind of like the base on which we'll build everything upon, the foundations, if you like, on which we'll build the house. So this makes about 10%, no more than that, of the final Gasworthy's winter forecast, and that's not usually released until sort of the very end of November or the start of December. So I mean, it's an important starting point, but it's not by any means the be-all and end-all. And the main thing is that when we get into the autumn, we start to look at all the other drivers that can affect the winter, such as the QBO, the quasi-biennial oscillation, and also other factors such as solar activity, and you know, all the kind of things that we look at in, so that kind of thing that we look at through the course of the autumn. So this is important, it's an important starting point, but it's not the be-all and end-all by any means. So I'm going to start off by just talking about the NAO, explaining what it is, and also what we're looking for in terms of Atlantic sea surface temperature anomalies during the month of May, and then we'll go on and do the actual forecast. So if you know all of this stuff, then I suggest you skip on by about 10 or 15 minutes. I have to assume that people are watching this for the first time, and every year is unique and has a brand new audience. So I'm sure there will be many people who will be watching this very first time who wants to know more about the NAO. So I'll start off with that, and then we'll do the actual winter 17-18 NAO forecast. So I'm just going to explain what the North Atlantic Oscillation is first of all. The North Atlantic Oscillation is an index that's reflecting the state of the atmosphere in the North Atlantic quadrant of the globe. So when the NAO is going positive, it's telling you that you've got low pressure around Iceland and Greenland and high pressure through the Azores and extending into Europe. And this chart here from the West Central Archive from the 4th of February 1925 is very, very indicative of a positive NAO. So we've got high pressure around the Azores, this area just here. It's ridging in towards the Bay of Biscay and into France and into Spain as well. To the north of it, we've got these purple colours. That, of course, is low pressure around Iceland and Greenland. And the gradient between the two air masses is producing this strong jet stream and this strong westerly wind that's coming across the Atlantic and into Europe. So a positive NAO essentially is Atlantic driven, it's mild, it's wet, it's windy, and you're going to have strengthened westerlies. And it's the default setup really for the UK and European winter. This is another pretty good example of a positive NAO. This is from the 1st of February 1933. Slightly different in that the high pressure is more centering around Spain and going into France. But nevertheless, it's still the same idea. High pressure is to the south. We've got all of this low pressure here up to the north. We're bringing in this strong west-southwesterly jet stream. So again, that's another pretty good indicative pattern of a positive North Atlantic oscillation. Now, when the NAO goes negative, you've got a very different setup. So I'm going to show you a chart now that's indicative of a negative North Atlantic oscillation. This is from the 14th of December 1878, and you can see that again we've got a complete flip, if you like, on what we were just looking at in terms of the positive NAO. So now, instead of having high pressure to the south, we've actually got lots of low pressure to the south. We've got low pressure running through the Azores. It's going into Spain, into the Bay of Biscay, into France as well. And instead of having low pressure around Iceland and Greenland and all those purple and blue colours, now we've got high pressure around Iceland and Greenland. We've got these yellow colours appearing. So it's telling us that high pressure is centered over Greenland, and it's also around Iceland as well. And what this does is that the squeeze, instead of bringing up a west-southwesterly, a mild flow, the squeeze between the air masses is actually bringing down this cold northeasterly or easterly type flow. So it's a total flip on the default setup. The default setup is a positive NAO. If the default setup is westerly, it's a total flip on that, where we have high pressure with the positive NAO setup. We now have low pressure. Where we have low pressure with a positive NAO setup, we now have high pressure. And this chart, again, from the December to Remember in 2010, very, very indicative of a negative NAO. So look how much blocking we've got, how much high pressure we've got around Greenland, and also extending up into the Arctic. Underneath it, we've got this big trough, which is actually the polar vortex, collapsing down across the west of Europe. And of course, we've still got low pressure underneath this blocking running into southern parts of Europe as well. The jet stream is on a very long way south. It's going down here somewhere, and this is allowing all of this cold air to push out of the north and out of the east as well, to deliver very cold and wintry conditions. So that's the difference between the positive NAO and the negative NAO. Now, what we're going to attempt to do is forecast the NAO for the coming winter, the winter of 2017-2018. And we do this by looking at sea surface temperature anomalies in the Atlantic Ocean in the month of May. This is an old UK Met Office methodology. Now, I wouldn't want to base an entire forecast on this. I wouldn't want to use just this aspect and say that is exactly what's going to happen in terms of the winter, because there are far more variables involved, far more drivers, if you like, involved in the weather. So it only makes up part of the forecast, and as I say, this is going to be kind of like the foundation of where we begin. Now, what I'm going to be looking for is a tripole, a three-way band of warm, cold and warm. But I'm going to start off showing you what we don't want in terms of getting a negative NAO. So I'm assuming that a lot of people watching this are going to be wanting a cold winter. Don't want a cold winter, then this is what you want to see. You want to see the Atlantic not showing a tripole. This is from the 16th of May 2006, and what we have here is just a very warm Atlantic. You notice that from Greenland up here down to the tropics down there, we've got sea surface temperature anomalies, but are just showing average to warmer than average from north to south. There's no distinct banding going on. There's no real cold area except perhaps for this area just down here close to the southeastern coast of America. But essentially the Atlantic is just warm from north to south. And you would look at that, and from that the forecast would be for a positive NAO, a positive North Atlantic oscillation, if that sea surface temperature anomaly profile was to reoccur in the winter. The UK Met Office did in fact predict, based on the sea surface temperature anomalies, they did in fact predict that the winter of 2006-2007 would have a positive NAO, would be a mild Atlantic-driven winter, and indeed that is how the winter of 2006-2007 panned out. This is from 2002. It's a different setup to 2006, but again it is indicative of a positive NAO. You notice this time we've got some colder than average sea surface temperature anomalies there off the coast of Newfoundland, but essentially the northern part of the Atlantic Ocean, this area just here, is quite warm, or it's close to average, and it's colder through the tropical Atlantic down there. So sort of the northern part is warmer, the tropical part is actually a little bit cooler. And again, that would be very much a signal for a positive NAO winter if we was to see that kind of pattern emerge through the winter. Of course, this methodology is assuming that the sea surface temperature anomalies that you have in the northern Atlantic Ocean during the month of May are going to reoccur during the winter. And that's when it's a bit, but I'm always a bit unsure about actually why that should be the case. I'm not entirely sure why that should be the case, that the sea surface temperature anomalies that you have in the month of May should necessarily come back in the winter. I suppose perhaps it's because May is kind of like the most calm month of the year in many ways in terms of Atlantic buoyancy. There isn't a great deal going on. It tends not to be great deal going on in the Atlantic in the month of May, and so it allows the Atlantic's natural state, which is varying year by year, it allows the Atlantic's natural state to emerge, and as you go into the winter, that natural state can begin to come back. Now, this is what we're looking for if you want a cold winter, if you want a negative North Atlantic oscillation, and you're looking for a tripod, which is 3 distinct bands. So you'll notice that just here we have a lot of warm sea surface temperature anomalies to the south of Greenland. Then underneath it, we've got this band of colder sea surface temperature anomalies, particularly focusing around the eastern coast of America. So quite clearly, it's colder through there. And then we come down through the tropical part of the Atlantic just here. And again, it's warmer. We've got a warmer band through the tropical Atlantic. This is from 2005, by the way. So 3 distinct bands of warm, cold and warm, and that's what we're looking for to be indicative of the chance of a negative NAO. Now, the UK Met Office this year, based on these sea surface temperature anomalies, did forecast a negative NAO for the winter of 2005-2006. We didn't get a particularly cold winter, actually, that year in the UK and the west of Europe. And I say that's because there's other drivers and other factors at work. So it was kind of a near-miss winter, really, the winter of 05-06. We did come close to getting cold winter, but most of the cold was actually in the east and the southeast of Europe. So even if we get the tripole through May, even if we can forecast a negative NAO based on that tripole, it still doesn't guarantee that we're going to get a cold winter. But the flip side of that is if we have a positive NAO forecast, that doesn't guarantee we'll have a mild winter. We can still have a cold winter after forecasting a positive NAO based on this methodology. That happened, for example, in the year of 2009, where the UK Met Office predicted a cold, I should say a mild winter, partly based on the positive NAO forecast from the month of May 2009, and in fact, winter of 09-10, as we know, was a very cold one. Our final example of a tripole is this one from 1995. Now, it doesn't really look like a tripole, but actually this is a tripole. What's wrong with this is just here. So we've got all this warm water just there, and then we've got this blue here to the western side of Greenland. That shouldn't be there. If you was to take that blue away, if you was able to take that blue away, what you would actually have is just a large area of warmer than average sea surface temperature anomalies to the south of Greenland. Then you've got this colder area here around Newfoundland and stretching down the seaboard of America. Keep in mind, this is a long time ago. This is 1995, so the projection is rather different compared to the modern charts that we use from NOAA. This blue area just here would be a lot bigger. We wouldn't have that blue area up there. We'd have an area of red, and this area just here where it's warmer, that would be further southwards and eastwards on the current projection. So essentially this from May 1995 is still a tripole. We're warm there, we're cold here, and this area is warmer. So as I say, it's a slightly different projection to the modern way that we view these charts, but it is still indicative of a negative NAO. The UK Met Office forecast a negative NAO for winter of 1995-1996 based on this methodology. Real turn up for the books, because most of the winters preceding 95-96 were actually mild or very mild going back to the early 1990s. So that's what we're looking for. We're looking to get a tripole. Let's now go on to the actual forecast part of this video. So we're going to start off with the sea surface temperature anomalies in the Atlantic Ocean on the 1st of May 2017. And this is how things were looking on the 1st of May 2017. Really, it's a north-south split, so we're warm through the tropics. That part is okay. Then we've got a cooler area just there, but we don't have a tripole because actually to the south of Greenland, it's quite cool as well. So this area is average to cool, and this area is warmer than average. We move on to the 8th of May 2017. Again, no tripole. What we've got, again, is quite warm sea surface temperature anomalies through the tropical part of the Atlantic again. We're cooler up here, but critically, where you will want to get a tripole, where you want it to be warmer, which is this area just here, we're average to cool again. So once again, we don't have a tripole, just have the northern and central part of the Atlantic looking quite cool and the tropical Atlantic looking quite warm. It's quite an unusual setup, but we can't call that a tripole. We move on to the 15th of May 2017. Very similar, warmer down here. Up here though, it's cooler, and up there it's cooler as well. No tripole. We go through to the 22nd of May 2017. And yes, we're still quite warm through the tropical Atlantic. We're still cooler in this area just here. This area to the south of Greenland is interesting because it's possibly warming up a little bit, but overall it still actually looks quite cool. And then we go through to the 29th of May 2017, the last chart for May 2017. And to be honest, we're probably not all that far away from a tripole here. We've got the warmer than average sea surface temperature anomalies through the tropical Atlantic. It is really quite cold to the north of it, and particularly close to Newfoundland, and that's quite an interesting area to have it quite cold. But again, to the north of that, whilst it isn't as cold as it is further south, it is still rather on the cool side. So it's this area to the south of Greenland, really, that's causing all of the problems. If that was warmer, then actually we would probably have a tripole. You'd be able to call a tripole there. It is very close to it, the three distinct bands of warm, cool, and let's say this area is warmer than the south of it, around this area just here, but it isn't warm enough, if you like. So that's why I'm struggling a little bit with this year's NAO forecast, because it's not that far away, particularly as we progress on through May 2017. It's not that far away from a tripole, if I'm being honest, but it's just not quite close enough to be able to call it. I've been trying to find some past years where things would be similar. So I wanted to have a look, first of all, at 2015. This was totally against a tripole. So this is from the 18th of May 2015. And notice the key with this is how cool it is through the tropical Atlantic there. And then it's warmer just here, and then it's cooler again up here. So actually we have got three distinct bands, but it's the wrong way from what we want. It's cooler, assume we want blocking. It's cooler in the north, it's warmer through the central part, and then it's cool again through the tropical part of the Atlantic Ocean. So that's kind of like the flip of the tripole. It's a reverse tripole, if you like. You would look at that and forecast a positive NAO, and boy did we have a positive NAO for winter of 2015-2016. Now the 2 years closest, going back to the 1980s, I've gone through all the years going right way back to the early 1980s, the 2 years that I can find that are closest to what's happening this year are both last year, 2016, and also 2011. So let's deal with 2011 first of all. We can see that this year we did have a fairly warm tropical Atlantic, albeit not to the same level as this year. And then it was cooler to the north of that through this northern part of the Atlantic Ocean, a little bit warmer closer towards Greenland as well. Not a tripole really, but I suppose if you was trying to come up with a match to this year, I'll take you back to this year, that's it, that's 2017. If you was looking for a match to this year, then I suppose 2011, what do you think? That would be reasonably close to what's going on this year. The other year, as I say, is 2016. Now, this isn't a perfect match either, because, yes, it is warmer in the tropics. That's similar to what's happening this year. But actually, this year, I think it's warmer through this tropical part of the Atlantic Ocean. And then these cooler sea surface temperature anomalies are actually more in the northeastern quadrant of the Northern Atlantic. So again, let's just get that out of the way. So this is 2016, this is 2017. You can see it's not all that far away, but not ideal, because the tropical Atlantic is warmer this year compared to last year, that area just there, and the cold anomalies, they're more over towards the western part of the Northern Atlantic, this area here, as opposed to last year when it was more over this area just here. So it's fairly close, it's reasonably close, but it's not an ideal match by any means. And I think, if anything, I would probably say that the NAO this year is closer to a tripole than it was last year. Last year wasn't really close to tripole at all. This year, it could be closer to a tripole. So I am struggling quite a lot. It's another unique year, and it's not a clear-cut positive NAO forecast, this. Now, last year, on the sea surface temperature anomaly, this one, what we actually forecast last year was for the NAO to be neutral to slightly positive. So we thought, yes, the Atlantic was still basically in a positive NAO type condition, but less so than the preceding years. I mean, overall, the Atlantic shouldn't be as big a player for the winter of 2016-2017 as it had been in previous years. And I think that worked out quite well, actually. That side of the winter forecast, winter 16-17 forecast, worked out quite well. It was a positive NAO winter overall, but less so compared to past years. And overall, the Atlantic wasn't as influential for winter 2016-2017 as previous years have been. This year, I think we've got to reduce that down even more towards neutral. So I think the Atlantic is going to be very set up towards a neutral phase of the NAO this year, possibly even going close towards very weakly negative. I wouldn't want to go quite towards a negative NAO forecast, because we haven't really got the tripole. But the tropical Atlantic Ocean is one area that I do like to focus on, and that's really quite warm this year. And then that cold area that we see there close towards Newfoundland, again, that's quite interesting. So I'm going to say a neutral Atlantic, a neutral NAO for the winter of 2017-2018. And that might be slightly on the positive side, or it might be slightly on the negative side. But always has to be a margin for error with this. So it might come out slightly positive. The NAO might come out slightly negative, slightly towards the negative side. Overall, I wouldn't have thought it'll be deviating all that far from neutral, unless other signals override it. So similar to last year, essentially what we're looking at here is the Atlantic being in a weakened state, and this allows, again, similar to last year, for other factors, other drivers to begin to become more influential. So things like the QBO, like ENSO, like solar activity, that kind of thing is going to be more important again this year, I think, as we do winter updates compared to some of the other years when the Atlantic, a good example of that is 2015, 2016, when the Atlantic has been very strongly set up for a positive NAO. Again, I'm not seeing, with the sea surface temperature anomalies, I'm not seeing a strong positive NAO setup. I'm seeing the Atlantic much weakened again. And this, as I say, it allows other drivers to become important. And those are the drivers that we look at through the course of the autumn. And the winter updates begin on the first Sunday of September, of course. So that's the NAO forecast. Again, we're going for a neutral NAO this year, and we might come out, because there's a margin of error, so we might come out either slightly positive or slightly negative. Overall, not expecting the NAO to be strongly positive or negative. Not expecting a strong NAO signal on either side, if you like. Close to neutral, and this allows the possibility of other drivers to become important as we head on through the course of the winter season, and those other drivers we'll be looking at during the winter updates. Right, that's it. Quite a complicated forecast. Hope you've enjoyed it. Remember, this is just the starting point for the winter. This is just the foundations. It's just kind of the flour that goes in to make the cake. We've got to add all the other ingredients, and those other ingredients will be thrown into the mix as we get through into September. So for the rest of the summer, enjoy what's left of the rest of the summer, and then come back at the start of September where the winter updates will begin, and we'll start to build upon this NAO forecast. And eventually, of course, at the end of the year, probably the 1st of December or sometime around 1st of December, we'll release the GasWeather's Winter 2017-2018 forecast. That's all for now. Thanks for watching.